All right. Okay. Hi everybody. I'm Olivier Lecompte. I'm a PhD student at Polytechnique de Montréal in mechanical engineering, and today I'm going to talk to you about human-in-the-loop reinforcement learning, which is a subject that I heard of during my AI class that I took last semester, and I thought it could be interesting and rehabilitation. For a rehabilitation purpose. So that's why I'm be talking to you about it today. So here's the content of my presentation. I structured all of my presentation as would be a background section in an article. So I'll first present a brief overview of what is reinforcement learning, so everybody can be on the same page. Then I'll introduce the concept of human-in-the-loop reinforcement learning before discussing an example of its standard application with the state-of-the-art DQN tamer algorithm. And finally, I'll present some relevant examples of how we can introduce a human feedback in the context of robot-assisted rehabilitation. So first of all, reinforcement learning, it's an algorithm that is designed to learn by experimenting. So in sort of a trial and error fashion, this type of artificial agent is implemented in a context where the training data is not labeled. So to do so, it uses a reward signal to learn, and the agent's objective is therefore to receive a maximum rewards for a reaction that it commits. The agent interacts with the environment through a sequence of observations, actions, and rewards. So, for example, at a specific instant, the agent receives an observation, then it takes an action from a set of possible actions that it could do and receives a reward accordingly. The policy is what defines the way the agent will choose an action. So training allows us to optimize the selection policy, which maximizes the expectation of the total reward. However, even with a state-of-the-art reinforcement learning algorithm, building an agent requires an important amount of trials due to the fact that it can be really difficult to match reward with a specific action. So to solve this problem, one solution could be, it's possible to introduce a human observer in that loop to train an agent with real-time feedback coming from that human, who immediately gives rewards for some action. It acts kind of like an ultimate heuristic, which is like when you try to give inputs to your intelligent agent based on the intuition of the user. So the main advantage of this modification is that to the existing like reinforcement learning architecture is that it provides immediate rewards, which accelerates the learning and also reduces the amount of trials that are necessary. The agent then learns by merging the signals Q and H, which I identified in my image here with red letters, which are correspond respectively to the estimation of rewards from the environment, and H is for the feedback from the human observer. So here's an example of an application of a reinforcement learning algorithm incorporating a human in the loop. The algorithm that I discuss here is the DQN tamer, which proposes to integrate a deep neural network of a framework called tamer into an already existing Q-learning algorithm. So the tamer framework, it consists of an intelligent agent in itself, which predicts human feedback and selects an action that is most likely to result in a good reward. So the reinforcement and meanwhile, the reinforcement learning algorithm is responsible for estimating the optimal action based on the environment's input. So DQM tamer trains the two functions separately, so H and Q, and it then evaluates the policy for each action included in the possible set and chooses the one that provides the highest reward. And the main article that this research group published, they are kind of the top of the line in that field. They add their agent playing different games. Like, for example, there was a maze and also a game called Taxi, which I'm not exactly familiar with, but the algorithm is. So the agent successfully mastered both of those games based on infos from the environment, but also on real-time feedback derived from emotions that were captured and displayed from the users. So as I illustrated in on my slide here, like it analyzes how the user is feeling about the move possible that the agent did, and so it can learn from that. And they even took it a step further by demonstrating adequate support for delays and other issues that might arise when implementing this algorithm in a real-world setting. Though they did not only did simulations, they also implemented it in real time. So as you can see here on the picture, there's a real car with a real maze, and the user gives the appropriate feedback by displaying like thumbs up and smiling. So the learning algorithm can learn better. So after I learned about this method, I initially thought that it might be interesting for the lab. So this led me to ask myself, in what other context could it be relevant to creatively introduce the human into the heart of the system? So I then identified two examples in the field of robotics-assisted rehabilitation, and I chose them mostly for their relevance in the context of our lab. But since the method is in its infancy, there are no examples of direct applications of human-in-the-loop reinforcement learning in robotic rehabilitation. So therefore, I have opted to present other creative ways to incorporate human subject that I found in the literature. So here we have a bio-cooperative approach for the human-in-the-loop control of an end effector rehabilitation robot. The authors of this paper chose a human-in-the-loop approach by including the human being in the robot control loop to develop their cooperative rehabilitation robot. So as a result, the robotic assistance can be changed by adaptively and dynamically adjusting the stiffness of a robotic arm and the arm gravity support, both of which we can see on the image that I put on the right of the slide. And we can adjust those different parameters on the basis of the subject's needs, which are estimated by means of biomechanical, but also psychophysiological measurements that are obtained from different types of feedback, such as visual, audio, and haptic. So, for example, they can evaluate the level of performance of the user, but also his level of fatigue, and then adapt their control accordingly. And this adaptive strategy, called assistance as needed, it allows personalized therapy and assisting the patients as needed in performing rehabilitation treatment. Also, I found another article that talked about a novel adaptive iterative learning control approach and human-in-the-loop control pattern for lower limb rehabilitation robot in disturbances environment. So this example is a little bit more basic, so I won't go into too much details, but the authors present a control loop including information that is monitored from a human subject to eliminate a deviation that they noticed in noisy environments between the actual trajectory followed by the robot and the desired trajectory in the patient's rehabilitation training. So this deviation could lead to unstable walking and even falling, but they were able to correct the situation by combining a neural network model to estimate the real-time desired trajectory from surface EMGs and an iterative learning controller, which reduced the tracking error quickly and ensures that the rehabilitation training effect of the patients is adequate. So yeah, in conclusion, I believe that human-in-the-loop learning can be an interesting avenue to explore for readaptation purposes. I think that we have a lot to gain by introducing human feedback from the user, a patient, or even a specialist, because it's a concrete way of integrating the experience or expertise of an observer in real time for your learning agent. So, and it's also an interesting avenue from a research standpoint, because it's never been addressed for robots-assisted rehabilitation yet. So I hope you got something relevant from my presentation, and that it sparked maybe your curiosity for that method. And thank you for listening to me.
Thank you, Olivier, for your presentation. It's very interesting, and the way you presented it, it seems we have a lot to explore regarding the human-in-the-loop reinforcement learning as it pertains to the application of rehabilitation assistance. So I would start by a few basic questions. If you go to your fifth slide, slide number 5, so here we have the human emotions as the feedback, as basically the signal that is provided by the actual human in the loop that goes to the agent besides all the observation and rewards. So in terms of reinforcement learning, what we get as the environment, basically the observations and reward, the reward has some kind of a positive sentiment to it. Okay, so it's like by accumulating rewards, so you're maximizing something that is good, and the agent is trying to learn based on the accumulation of rewards. How about sentiments? How about the feedbacks? For example, here from the faces or the body languages of the humans, you can understand basically the sentiments and attribute them to positive or negative feelings that can be fed into the agent again. So that's somehow clear. The relationship between the reward and the signals coming from the human feedback is clear. But if you go to slide 8, here the feedback from the human that is in the loop is not clear. What is the feedback from the human in the loop here?
Actually, as I said, it's not exactly the same thing, because there are no learning agents. Like they just modify the controller gains. They update it on based on the different types of signals from the human, which are biomechanical, like such as the elbow position and everything, but also from they can estimate the level of fatigue. So then that's how they can modulate the help that they provide to the user.
And how would you think one can estimate the level of fatigue for a user?
Actually, from what I understood, it was mostly based on the effort that they measured from their EMG acquisition.
Okay, that's nice. So EMG can be
that was an input, but also they were not as clear as what kind of psychophysiological measurement they used to estimate that. Maybe it was from prior works that I didn't get to, but yeah, they try and get better understanding of how the patient is like feeling throughout the rehabilitation.
Or there's another indicator of the effort that human is making, or the energy that it's consuming. I think last time Amir mentioned something about this, right?
Yeah, we talked about masks for
exactly. So the oxygen consumption. So that's actually one interesting idea of implementing these kind of feedbacks to human in the loop. So human in the loop simulation, it's relatively but it's an old field of application. So it's been around for the past maybe 20 years, 30 years maybe. But reinforcement learning as a new concept with the use of new processors and like powerful computers, it's a new thing, and just feeding back into this loop, the human emotions, the human feedback is actually quite interesting and new. Okay, so
that's why at the beginning I said like I structured my presentation as would be like maybe a background section in an article. That's because I talked about like how in other fields they can use now reinforcement learning with a human in the loop, and then I showed also examples where there's no reinforcement learning, but we can already use like a human feedback in the loop. So I just wanted to illustrate that there's a kind of a space that is not investigated in the research right now.
Yeah, actually that was the idea, and it presented quite nicely. I think it's an open area that we can ideate, we can talk and just share some ideas about, and maybe we can implement it someday in our
and in a context of like training and rehab, like it not only can you have like feedback from the user, but as I said at the end, like maybe get some inputs from real experts in that field. So the algorithm, the agent doesn't have to learn everything from scratch. It can be like is like knowledge bank on inputs from like real specialists.
Okay, very good, very good. So that takes us to Theo, who has a question, and I think his project is quite similar to what we're thinking about today. Yeah, go ahead, Theo.
Yes, thank you, Olivier, for your presentation. I was wondering in the Tamer, slide 5, like the the human feedback for the emotion detection, like it's pre-trained, so you always train in the process of like learning the game.
Actually, the tamer part of the algorithm is like another agent in itself, and it's previously trained to like, I think there's a first layer that determines what are like the different emotions that are perceivable, and afterwards it translates it to like the right format for the feedback for the Q learning algorithm.
Okay, so basically you actually need like extra data and label data to identify the emotion in the face, and then use this information to
But for now, what I saw is like the feedback from the human. Like for now, it's not like a continuous. It's like not like a domain. It's more like a discrete set of feedbacks. So they started with a binary thing. So like it's good, it's bad, and afterwards they can like have a discrete set of options.
Okay, and also I was wondering, like, we're technically intervening in the algorithm. Like, the feedback is part of the reward function, or is it something else?
Well, the agent is like kind of a fusion, like if you do a sensor fusion, or if you do like a cost function or something, they attribute different weights to the signal H and signal Q, and they learn from that. So if you want to like give more weight to the yeah, to the observations and rewards that come from the environment, you can do it. And afterwards, they examine like every action that's in the possible set of actions, and the action with the highest reward is chosen to be executed.
Okay, so the feedback is part of the reward function. Sorry.
Part of the what?
The feedback from the human.
Yeah.
Like, is it like if it's a good or a bad move accordingly to the human? Like, is it part of the reward function?
Yeah, it's part of the reward function. It's like you attribute a weight to the reward provided by the environment and a weight provided to the feedback from the human. You add them together, and that's like your reward for your action.
Okay, so yeah, so there's no actual modification of DQ and just okay.
Yeah, you just add something to it.
Thank you.